Okay, final question, which is on chapter 11. So 10a, the mass of the nucleus for thorium is 234.04359 atomic mass unit. So what do we have? We have the mass of nucleus for thorium, which is 234.4359 U. Okay, and then we have to determine the mass defect. So mass defect is delta M in atomic mass unit and kilograms for thorium, which has 234 nucleons. So it has 234 nucleons and proton number of 90. 234 nucleons is A, and then we have the proton number, which is Z 90. Kan? Betul kan? Yeah, okay. So delta M is equal to ZMP plus NMN minus mass of the nucleus. Okay, and from here, how do we know what is the value of N is A minus Z? So we will then get 144. Okay, alright, so from there you can then directly calculate the delta M, which is equal to 1.8591 U. That is in atomic mass unit. So we now need to convert it into kilogram. So in order for us to do that is we are gonna multiply this with 1.66 times 10 to the power of negative 27, so that we can get this mass defect in kilograms. So the answer is 3.09 times 10 negative 27 kilogram. Okay. Alright, Roman 2 pula, we have to calculate the binding energy. The binding energy in joule. Semuanya ada kena bagi tadi di sini. Okay, so the binding energy is calculated using the equation delta mc square. Okay, so delta m is, it wants the energy in joule, so we are gonna use the kilogram unit. Okay, so 3.09 to lah, times it with 3 times 10 to the power of 8, which is the speed of light. So you will then get the binding energy to be equal to 2.78 times 10 negative 10 joule. Alright, so that is on question A. Question B pula, a sample of a radium element with a half-life of 1600 years. So given is the half-life in years, decays by emitting alpha particle. So it emits alpha particle producing the element radon. Determine the time required for 60% of the sample to decay and produce the new element. So 60% of the sample, meaning it is the number of radon left lah. So number of radon left is 60%. And so the original I would N naught lah actually. So N naught is the 100% lah, awal-awal the 100% kan. After that we are left with the radium element, mestilah 40% saja, because dia cakap producing element radon, so 60% tu mestilah pergi radon sebab dia decay. So this is radon, this is radium. Alright, and then what else? Oh, we have to use what formula? We are going to use the formula N equal to N naught E negative lambda T. Okay, so from here we need the decay constant, which is equal to lambda ln 2 divided by the half-life. So this one you will use apa tu nama dia? In years lah, okay? Sebab dia tidak minta untuk dalam second atau days ka, dia cakap. So we are just gonna stick with years. Okay, so this is the equation for remaining nuclei. So we are gonna use this one. So N left is 40% lah. Okay, so this is 40, and then the original is 100. So E negative lambda T. So 40 divided by 100. And then this is E negative lambda T, and then you times it with ln. So you are left with ln 40 over 100. And then this one, ln E equal to 1 kan. So kita kasi turun this down. So and then we are left with t equal to 2115 years. Okay, so if you do have any problems solving this question, just let me know. But before that, let me just calculate something. Okay, so when you calculate this ln here, it should be negative, negative 0.91 something. So if you get negative here, add a negative here, then the negative can be cancelled. Okay, remember, the time cannot be in negative. It can only be in positive value. Alright? Okay, so that is the end of our discussion for our pre-PSPM and for question number